Now let us complete the last part of chapter 8, the tests for amphoteric hydroxide. We explained this in chapter 5, in page 127, in the blue table or the blue box, the study tab here. The study tab, I told you before that you must memorize this table very well, and I told you here also to write a note. We will take it with a chapter 8, this one. If you remembered, we did not explain anything about that except in hydroxide amphoteric are metals that can react with both, with acids and bases, as we said here. We said that the amphoteric hydroxides are zinc and aluminum, and they act as an acid and they act as a base. So today we will explain it in more details. That's why I did not ask you about the equations in the previous exam. Anyway, the general rule, acid with an alkali equals salt and water. In this case, if I bring zinc hydroxide and react it with sodium hydroxide, look, sodium hydroxide is a base and zinc hydroxide is also a base. But if I want to collect or to calculate, let us say, the priority for everyone, which one has the priority to be a base, the priority will be for elements, the representative elements. I mean the elements that are from group number 1, 2, and 3. Any element from the transition metals, especially zinc, and from the representative metal from group number 3, aluminum, can act as both acid and a base. So, if I have two hydroxides and they are competing with each other to be a base, the strong one is the element that is related to group number 1 or 2. So here sodium is in group number 1, while zinc is in the transition metal. So sodium will act as a base in this case, and zinc will act as an acid, even if it's ending with hydroxide. So zinc will act as an acid if I react it with a strong base such as sodium hydroxide. The product is unacceptable product. It's not a normal salt. The name of the salt is sodium zincate. Sodium with zinc with oxygen. Its name is sodium zincate. How can I predict it? Actually, there is no a rule like the previous rules. If you remember rule number 1 and 2 and 3 and 4, we have taken 4 rules for the reactions of acid and alkali. But in this case, I cannot give you a specific rule because this is an amphoteric hydroxide, and the name of the salt actually is unpredictable name, which is sodium zincate. And as I told you before, chemistry is an observative science. So they are doing the reaction, and they, after that, record the results, and they say that the result or the compound is like this, has this formula. So you must memorize it. Unfortunately, this chapter you must memorize many things, many equations. So the product, you must memorize it, and you must memorize also the formula. Na2ZnO2 plus water. Also aluminum. I told you that aluminum here is an amphoteric hydroxide. So again, if I react aluminum hydroxide with sodium hydroxide, the priority for the basic compound is for sodium because it's in group number 1. It's stronger, more reactive than in group number 3. So the product will be sodium aluminate, sodium with aluminum with oxygen. You must memorize the name, memorize the formula, plus water. I'm sorry to tell you that you have to memorize it, learn it by heart as it is. There is no any rule to help you to memorize these kinds of compounds. So these are an exceptions. You must memorize them as they are. Okay. Let us explain this in more details in this note. Okay. The amphoteric hydroxides has also another property. They redissolve if excess sodium hydroxide is added. That's why they are amphoteric. Now, I told you that they are acting as a base. طيب, مش they are acting as a base. Let us go back here. Sodium zincate is a salt. But this sodium zincate, if I add an excess base, يعني, if 1 millimeter of sodium hydroxide must react with 1 millimeter of zinc hydroxide, and I added after the reaction another 1 millimeter as an excess sodium hydroxide. If I add an excess amount of a base, this salt will redissolve again to give us zinc hydroxide. So this is a property, the main property for the amphoteric hydroxide. They are forming an unstable salts. What means unstable salts? Means that these salts, zinc, sodium zincate and sodium aluminate, will redissolve if I add an excess base. They are unstable salts. So the amphoteric hydroxide like zinc and aluminum will form unstable salts if I add an excess base to them. So again, zinc sulfate here will react normally with sodium hydroxide to give us zinc hydroxide and sodium sulfate. Type. What is the relationship between this equation and the equation that you saw it before? Here we are explaining how can I prepare zinc hydroxide. يعني, this equation told you that I have zinc hydroxide. From where can I get the zinc hydroxide? Here we started from zinc hydroxide with sodium hydroxide without telling you from where can I get zinc hydroxide. In this equation, we are explaining the process of preparing zinc hydroxide. So, zinc hydroxide is prepared by a reaction with sodium hydroxide with zinc sulfate, a salt. By a double displacement, sodium will react with sulfate and zinc will react with hydroxide to give us zinc hydroxide and sodium sulfate. This thing, the zinc hydroxide, again, move it here, this zinc hydroxide, and react it with an excess what? Excess base. You will get a salt, its name is sodium zincate, which is a colorless solution. Why it's a colorless solution? Because we are adding an excess salt. If we add a limited amount of base, we will get a solid one. You will take this in more details also in chapter 12 in grade 10. So, the story of the amphoteric hydroxide is repeated into 3 chapters. Chapter 5, acid base. Chapter 8 here, the test for cation and anion, or the test for amphoteric hydroxide. And you will take it later on in chapter 12, also in more details with more colors. So the only thing that you have to know from this rule that zinc hydroxide is an amphoteric, so it will redissolve, look, solid with an excess base, redissolve to give us a salt. This salt is unstable, as I told you, and I can prepare zinc hydroxide from zinc sulfate. Type. Go to aluminum. Okay. Aluminum sulfate can react with sodium hydroxide to give us aluminum hydroxide by a double displacement reaction. Aluminum hydroxide, which is a white precipitate, you must memorize the colors. By the way, this is a white. They are asking you about the color of the precipitates in a multiple choice question, so take care about that. The white precipitate will react with an excess sodium hydroxide to give us sodium aluminate. You must memorize the formula and the name, plus water as a side product, which is a colorless solution. Both of them colorless solution, forming a colorless solution if I react them with an excess base. So this is the whole story for the amphoteric hydroxide. And by this note, we will finish. This is the last note. So by this note, we will finish the chapter 8. If you open this chapter from your book, you will see that we skipped page 221. This page. Okay. Page 221. This page is related to the concept of electrolysis. So we will take it in grade 10 with chapter 4. So please write here a note will be taken right here